Okay, this is Mrs. A with another How to Solve a Polynomial experience. So sometimes we get a polynomial and we have to solve it, and we just look at it and we are lucky. We know the method we want to take just by looking at it, based on our understanding of the polynomial and based on our experiences. But what about when we're not so lucky? When we look at it and we're not sure how to move ahead? Too many of us are just applying the quadratic formula willy-nilly without giving it any further thought. Well, what Polya would say to do is to use his problem-solving approach. This is something we've used since back in 5th grade, which is understand, plan, try, and look back. And we can use this for polynomials. And by planning and justifying our method before we solve it, we will be more efficient problem solvers and we will avoid errors. And so what we see by doing this approach is the quadratic formula is not always the best approach when we're not sure how to move forward. And if we give it a little bit of thought, add a little bit of heuristics to our methods, then we will have a very efficient and accurate approach. Let's give this a try. So the way I do this is I practice simply justifying a method. I put everything else aside and I hone in on my skills for how do I justify a method before I try it. Let me give you an example. So Polya's method, we always start off with, when we use applying to polynomials, we start off with making sure that it's in its simplest form and that it's standard before we even start the problem. And for this exercise, all I want to do is understand the structure of that polynomial and then decide what method based on that structure will I use, and I make sure I can justify it. I'm not going to solve it because I just want to practice over and over again justifying my method. And then I do want to look back, but I only want to look back at the approach because I'm not going to solve it. I don't need to see if my answer holds water. I just want to see how does my approach that I selected compare with other approaches. And the way I do that is I'm going to go out to technology tools to see what other software would recommend as the best approach. Okay, let's give this a try. So let's start with, this is just a list of basic problems that were up in a high school textbook. And what I liked about this set is that they wanted us to solve by any method. And this is where we have to think about what method should we move forward with. So let's give this a try. So we have 6 possible ways that we can move forward. I'm not sure if you've ever thought about that. You know, we keep learning all these methods, and did you ever take a step back to think about there's really only 6 ways to move ahead? We can do the square root method. We can use identities. We can use factor methods. We can use the quadratic formula. I also like to throw Lowe's method. It's the direct method, and I think that it actually works faster than quadratic formula. For the case of this, though, let's stick with just the quadratic formula because a lot of people don't know the direct method. And then we could do completing the square method and use substitution. I'm also going to take use substitution off the table for this set of problems because it's a little bit more complicated. And I really want to focus just on how to select the best method. Let's give this a try. So we've got 5q squared minus 3q minus 3 is equal to 0. We said the first step is to always make sure that it's in standard form, that it's simplified. And if I look at this equation, it's definitely it's in standard form and there are no common factors, let alone greatest common factors. So I am going to understand the structure of this equation. So I've got a leading coefficient of 5. I've got prime coefficients, and the reason I care about that is it means I'm not going to have a lot of factors available to me. However, since they are small, I can maybe do this mentally in my head. And let's see, it's a quadratic, it's a trinomial, and the coefficients are not perfect squares or cubes. And anything else I want to think about? Oh, the discriminant. The discriminant would be 9 plus 60, so it's positive. So my solution set are going to be real values. That gives me a good snapshot of the polynomial that I'm dealing with. So let's see. What type of method would I use to solve it? Let's give this a try. Well, the square root method, that's really intended for problems that are of the pattern x squared is equal to b. And the idea is that we would take the square root to isolate x. So no, I don't think that that's going to help us here. Identities, we just said that there's no perfect squares, no perfect cubes, and most of the identities that we've learned have are all involving that. And we look at the identities list, there's difference of squares, some are difference of cubes, perfect squares, perfect cubes. So that's not going to help us. So I'm going to eliminate that as an option. The next would be factor methods. Now definitely factor methods I think would work well here. So that's going to be one of my possible solutions. Quadratic formula, if I can get the factor method to work, I will use that first because the quadratic formula involves working with radicals and rationals or fractional amounts, and so I'd rather use the factor method if I can. And the last is complete the square, and if you've seen my prior videos, you know that I am not a fan. One of my heuristics is to not use complete the square unless told to. So more information on that, use only if the problem asks me to, or ask for the equation in vertex form, and monitor really closely for accuracy. Because what I had found when I developed this heuristic is whenever I use complete the square, I tend to not get a correct answer. And so I tend to avoid it because there's always a different way to solve it. So I'm going to put an X on that. That leads me to two possible methods to move forward. I can factor or I can do the quadratic formula. If I look at my factoring methods, I might want to do backwards FOIL, mental math, but I don't do mental math whenever I have a leading coefficient because I'm not that good at that. I can do product sum factor. I could use the diamond game. I could use snowflake. If I do the diamond game, I have to do it with grouping, and that tends to be the approach I take. If you're more comfortable with snowflake, that would be fine too. So my choices are to factor or quadratic formula. I'm going to try to see factor first. I'm not going to solve this, but I am going to just quickly see if I can easily factor this. And if you remember, the approach for the diamond game is simply A times C. And we put B down here, and then over on the left and right side we put the factors. So A times C is equal to negative 15, and B is equal to negative 3. And there's not that many factors for negative 15. There's only 15 and 1, which definitely can't be summed or subtracted to get to 3. And there is 5 and 3. And again, those can't be put together to make up 3. So right away, I am seeing that the factor method has to be taken off the board. And that leaves me with one approach, which is the quadratic formula. Now you're saying, but Mrs. Amarcia, if I just always do the quadratic formula, I would have gotten there. But moving forward, we're going to start to see that if we did choose the quadratic formula every single time, we would be wasting a lot of time because there's just simpler approaches. Okay, so I'm not done yet. I have my method, and I can definitely justify it by process of elimination. And I want to now, last thing, look back at it. How does my approach compare with others? Now, if I have a friend around or if the teacher is giving me the answer on the board, I can see how did my approach compare. But there's also solutions that are out on the internet these days. There's tools where we can get the step-by-step process, and we don't want to use those to solve for us, but they sure are handy to compare our solutions against theirs. So let's see. We've got 5q squared minus 3q minus 3. 5q squared. Here we go. Okay, so we've got 5q squared minus 3q minus 3 is equal to 0. Now this is Wolfram Alpha. It's one of many packages. I can quickly list them. There's one from Microsoft. There's one called MathWays. There's MathPapa. There's this Wolfram Alpha. And there are a number of other ones where they actually solve and give you the steps. And let me show you. The problem is a lot of them these days actually are starting to become expensive to use, and that's problematic. If these tools were 99 cents, with all the tools that we need to get to be good mathematicians, I would think that would be fair. But, they all want like $11.99, $9.99 a month, and this is just getting crazy. Come on, math companies, make it a little bit more accessible. All right. I'll get off my soapbox and back to this problem. So Wolfram Alpha, if I look at the step-by-step solution, I get down here, I click on it. See, again, they want me to go pro. And so they give me complete the square as the possible solution. And I had mentioned before that I'm not a fan of complete the square, but let's look at the complete the square approach and look at all those lines and work that we would have had to have done. And let's compare that against quadratic formula. See, look how short and easy that was. So I feel really good. The only two options that were available to us that would have worked with this formula, you notice how they didn't offer us factoring, were the quadratic formula and completing the square. And we saw that the quadratic formula was actually shorter. We'd get to the answer more directly, which means it's more time efficient, and we probably get a higher accuracy. So let's go back to here. So what I would do is I would say for number 51, I would have chosen, let's go back to the list, I would have chosen number 4, and I'd be really happy with that approach. And so try that method for each of the next 5 problems and see what you get, and then come back and let's compare and contrast.